Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble codes DTC P0201 and P0204, which indicate injector circuit malfunctions for cylinders 1 and 4 in the 2015 to 2020 Honda Fit. These codes point towards issues involving the fuel injectors, integral components in the vehicle's fuel system responsible for delivering fuel to the engine. Situated within the engine compartment, the injectors receive electrical signals from the powertrain control module, PCM, which controls their operation to ensure optimal fuel delivery. A malfunction in this circuit can lead to poor engine performance or failure to start. Understanding the specifics of these DTCs and their implications ensures an informed approach to troubleshooting and resolving the issues effectively. The DTCs P0201 and P0204 specifically denote failures in the injector circuits for cylinders 1 and 4, respectively. The fuel injectors play a critical role in the vehicle's ability to perform optimally. Their primary function is to deliver the right amount of fuel to the engine's combustion chambers, precisely when needed, as dictated by the engine control module. Located in the engine compartment, faulty injectors can lead to various performance issues or may prevent the engine from starting altogether. Understanding this relationship between the injector circuits and engine performance is crucial for diagnosing and rectifying the hindrances caused by these DTCs. Several possible causes for the occurrence of DTCs P0201 and P0204 need to be considered. First, open wires in the circuits connecting the injector can prevent proper operation, which includes wires leading to the powertrain control module, PCM. Additionally, poor electrical connections or loose terminals at the injector can trigger these codes, indicating that it is essential to inspect these areas closely. The injector relay itself may be malfunctioning, either failing to provide electricity to the injectors or allowing inconsistent voltage levels to impact performance. Lastly, shorted wiring or the improper grounding of electrical components could exacerbate these issues, leading to injector malfunctions. The symptoms associated with DTCs P0201 and P0204 manifest through various symptoms primarily affecting engine performance. Often, the engine may fail to start altogether due to a compromised fuel delivery system, which can be detrimental in the initial diagnostics. Additionally, if the engine does manage to start, one might experience rough idling as a result of insufficient fuel reaching the combustion chambers. This can lead to noticeable loss of power during acceleration or operation, ultimately affecting drivability. Over time, poor fuel economy can also be a direct consequence of these injector circuit malfunctions, as unburned fuel signifies that the system is not functioning correctly. In the first troubleshooting step, the technician should ensure the vehicle is in the on mode. This is essential for enabling proper functions of diagnostic systems. Next, clear any existing diagnostic trouble codes using the Honda Diagnostic System HDS. After clearing, the engine must be started, and if it does not start immediately, you should crank the engine for approximately 20 seconds. Following this procedure, the technician should check for any pending or confirmed DTCs using the HDS, as it will provide valuable insight into potential faults. Confirming the presence of P0201 or P0204 indicates a replicable issue, thus warranting further investigation. Step 2 focuses on performing an engine starting check. The technician will attempt to start the engine at this stage to ascertain if it successfully engages. If the engine does start, there are further steps to consider that link back to investigating the injector circuit. A successful start implies that the initial electrical and fuel supply conditions might be suitable. However, further inspection is essential to rule out any intermittent failures. Conversely, if the engine does not start, it necessitates proceeding to Step 3 to perform a relay check, indicating a potential issue with the injector relay or associated circuits. Step 3 requires turning the vehicle to the off or lock mode first. This is imperative for safety reasons and ensuring the appropriate electrical state for testing. The next action involves removing the injector relay, denoted by letter A, from the underhood fuse relay box. After removal, it is crucial to test the injector relay to confirm whether it is operational. If the relay passes the test, this indicates that it is functioning correctly, prompting the technician to continue troubleshooting with Step 4. On the other hand, if the relay fails, it will need to be replaced, as a defective relay will directly affect the injector's operation and can lead to the symptoms previously described. In this step, the technician will turn the vehicle back to the on mode, necessary for ensuring that electrical elements are powered sufficiently to conduct tests. They will then measure the voltage between specified test points in the injector circuit, particularly focusing on the FI main RLY outline. This involves checking between the injector relay socket number 3 and a solid body ground. If battery voltage is present at this check, it implies that the FI main RLY outwire is intact and functioning correctly, permitting progress to Step 5. However, if voltage is absent, it indicates an open circuit requiring repair between the main relay and the injector relay. Moving on to Step 5. The technician again turns the vehicle to the on position. The process involves measuring the voltage between the appropriate test points for the +B INJ line, including the injector relay socket number 1 and a body ground. Confirming presence of battery voltage ensures that the +B INJ wire is functional and allows progress to Step 7. If this voltage is not detected, it necessitates further investigation, as circuit integrity could be compromised. Identifying issues in this wiring line is a critical step towards ensuring the injectors receive the proper electrical signals needed for their operation. Step 6 focuses on checking the integrity of fuse number B10, which is rated at 20 amps and is located within the underhood fuse relay box. A functional fuse is essential for ensuring that electrical current flows to the relevant circuits, including the injector circuit. If the fuse remains intact, repairs should be made to the +B INJ wire between the fuse and the injector relay. Removing and inspecting the fuse will indicate if it has blown. In that case, it would require replacement. If the fuse is found to be good, this step emphasizes the importance of ensuring that power is consistently delivered throughout the circuit. During Step 7, the technician proceeds to check the injector relay's operation relative to the INJ RLY CL line by measuring voltage between specified test points in a momentary context. After switching to the on mode, it is confirmed if the relay is receiving the necessary signals. If battery voltage is registered, it confirms the functioning of the INJ RLY CL wire, thus leading back into further troubleshooting if problems persist. If not, this triggers a closer investigation into possible open circuits between the injector relay and the PCM, powertrain control module, which is critical for the injector's performance. Moving on to Step 8, the technician should set the vehicle to the off or lock position once again before conducting this part of the troubleshooting procedure. A crucial step is to jump the SCS line, which refers to the SRS control unit shorting wire, using the HDS to establish proper testing conditions. Following this, the next action is to disconnect the PCM connector A 51P prior to checking continuity between test points located at the injector relay. This involves validating connections to ensure that the INJ-RLY-CL wire remains functional. And if it fails this test, repairs must be made to any open segments found in the wiring between the injector relay and the PCM. In Step 9, the vehicle will again need to be set to the off or lock position to ensure safety and proper electrical conditions. The technician must connect terminals A and B with a jumper wire between the injector relay socket terminals number 1 and 2. Then, by jumping the SCS line with the HDS, they can prepare for the next diagnostic. It is essential to disconnect the PCM connector A, number 51P, before measuring the voltage between specified test points focused on the PCM. If battery voltage is established, it confirms the integrity of the INJ-RLY out wire, leading to further steps. Otherwise, the technician will need to repair any identified open sections in that wiring segment. During Step 10, the technician should revisit the diagnostic trouble codes checked originally in Step 1. This provides a concise means of establishing whether DTC P0201, indicating an injector circuit malfunction for cylinder 1, is still present. If confirmed, it directs the technician to Step 11, which continues addressing the issue directly. If the code is not present, this indicates that the injector circuit may have self-corrected, or an intermittent fault is present. Hence, further exploration into the possible loose connections or electrical inconsistencies must be assessed carefully to ensure that the system is operating correctly. At Step 11, the technician will switch the vehicle to the off mode and install the injector relay that's been previously tested. Establishing continuity between the two specified test points for the INJ-H1 and INJ-L1 lines is the next key action. This involves utilizing a multimeter to assess whether the 2 points are electrically connected, which indicates that the wiring is intact. Should continuity be confirmed, there's a strong likelihood that the wire integrity remains secure, which allows evaluation of other components. Conversely, if continuity fails, the technician must address any open wiring issues found between the injector and the PCM. Step 12 involves disconnecting the number 1 injector connector for isolating specific faults within the injector circuit. The technician will then check continuity between specified test points for the INJ-H1 line. This is crucial for determining if the wiring is intact between the number 1 injector and the PCM, which can affect signal efficacy and proper injector operation. A successful check would indicate that the wiring integrity is solid. If continuity is lacking, the technician must repair the identified open circuit as part of the resolution steps. This systematic approach allows ensuring that each component is functioning as required before replacing any parts. In Step 13, the focus shifts to checking continuity specifically for the INJ-L1 line. The technician must ensure that this line remains continuous between identified test points while the number 1 injector remains disconnected as a part of the isolating process. Validating continuity is essential in determining whether the injector circuit is intact and functioning correctly. If continuity checks out, it indicates that any failures likely lie within the injector itself rather than the wiring system. This could suggest a failure in the number 1 injector, prompting its replacement along with other injectors as a set. Should continuity not be established, this indicates an open line needing repairs. Step 14 requires disconnecting the number 1 injector connector once again to allow for safe voltage measurements across test points in the INJ-H1 circuit line. By measuring amperage while the vehicle is in the on mode, the technician can confirm whether there are any unintended voltages present in the line. If any voltage readings are present in this test, it indicates a short-to-power situation that must be corrected. Repairing this short circuit is crucial to ensure that the number 1 injector operates as designed, without undesired electrical interference. If no voltage is detected, it leads the technician to proceed with additional checks for the circuit's integrity. Continuing also with Step 15, the technician checks for voltage specifically within the INJL1 line by following similar measurement protocols as previous tests. This involves measuring voltage between the designated terminals while ensuring other circuit elements remain disconnected. Detecting voltage at this stage would indicate a short circuit condition requiring immediate repairs. Conversely, not finding voltage indicates that there is no current leakage or undesired signal propagating through the system, allowing for further evaluation of the wiring and connections in subsequent troubleshooting steps. Each measurement provides critical information so that the technician can navigate the troubleshooting path correctly. Step 16 focuses on verifying the integrity of the INJH1 wire through continuity testing while the vehicle remains in the off state. This step emphasizes checking between specified test points to ensure that continuity is maintained without interruptions in the wiring path. If continuity is confirmed, it indicates that the wire is adequately functioning and free of faults. This would allow proceeding with further diagnosis on the injector's operation. If continuity is not verified, it would require repairs to the open segments found in the wiring, ensuring that each connection plays a functional role in the overall injector performance. During Step 17, the technician will perform continuity checks for the INJL1 wire, while ensuring that number 1 injector remains disconnected. This is vital to ascertain that there are no faults or breaks in the wiring path between the specified terminals. Confirming continuity indicates sound wiring without any obstructions, allowing for assurance that the injector can function correctly. If continuity fails, it indicates the existence of an open circuit necessitating repairs. By meticulously following these procedural checks, technicians ensure a methodical approach to isolating faults and identifying the root causes of the injector-related DTCs. In Step 18, the technician shifts focus to the number 4 injector, ensuring its disconnection for isolated checks. Checking continuity for the INJH4 line allows for a focused approach to assess the wiring that affects the operation of the 4th cylinder's injector. Continuity verification is fundamental in determining whether the wiring system remains intact from the injector all the way to the PCM. Confirming continuity here implies reliable wiring, free from breaks. Conversely, should continuity not establish, it necessitates repairs to the identified segments of the INJH4 lines, ensuring all connections are robust for optimal injector functionality. Step 19 involves performing a continuity check for the INJL4 wire, which is critical for verifying the integrity of the circuit linked to the number 4 injector. Following proper testing protocols while ensuring connections remain disengaged, the technician checks specified test points to establish continuous electrical flow. If continuity is present, it suggests the wiring remains intact, whereas a failure indicates an open circuit, prompting necessary repairs to restore functionality. By investigating the INJL4 paths, technicians can effectively focus on ensuring all elements of the injector control system are operational. After completing the necessary repairs, final verification is essential. This process involves confirming that all components of the injector circuit operate as intended. The technician should utilize the Onboard Diagnostics 2 OBD-II system to conduct a final check for any remaining DTCs, specifically looking for P0201 or P0204. A successful absence of these codes would indicate that the issues have been resolved. It's equally pertinent to ensure the engine operates normally without any further performance issues, thus confirming that the troubleshooting and repair phases led to effective solutions. Confirming all systems are functional underscores the success of the diagnostic and repair process. Preventive maintenance is a proactive approach to avoid future issues related to injector circuit malfunctions. Routine checks of the injector circuits should be conducted as part of the vehicle's scheduled maintenance to identify any wear or damage early. This includes inspecting wiring connections for corrosion or loosening, as these poses a risk for intermittent issues arising down the line. It's also vital to ensure that the injector relays function correctly, allowing for proper electrical flow to the fuel injectors. By adhering to these preventive measures, vehicle owners can maintain robust engine performance and avoid the inconvenience of unexpected breakdowns. In conclusion, comprehending the implications of DTCs P0201 and P0204 is fundamental for addressing injector circuit malfunctions in the Honda Fit from 2015 to 2020. Following a systematic approach through each diagnostic step helps ensure thorough inspections, identifying areas of concern, and confirming circuit integrity. Each step provides valuable insight into potential failures within the system. Moreover, understanding the various components involved, from fuel injectors to wiring, equips technicians with the knowledge needed for effective troubleshooting. By implementing careful diagnostics and preventive measures, vehicle performance can be preserved and maintained for future reliability. Please like and subscribe to the channel. See you next time.